Hey everyone, this is Keith, and today I'm going to explain about the project we've done. And we were the team A, and as you can see, we have the architectural diagram on the screen, and I will explain you and I will show you the function, how they are being used and connected together. So what we're using a couple of Heltec devices. They are very small devices, and they connect to the TTN network. So this is supposed to go on the drone, the very first node that you see over here. Then there's another one which is connected to a USB device to a computer to send and receive data through LoRa PNP. After that, the data travels. One copy is sent over to the local base camp, and in there we store the data. And then from there, the data is being served as an API, as a local Basecamp API to serve the website. The second part of the data is traveled through the USB connection, and then it is connected to a Bluetooth device. So the computer has a Bluetooth device, and we have another setup here. So this is what you're seeing here is um, there is, let's see, okay, so over. So there is an Arduino board and a LoRa Shield attached on top of it, and this is a Bluetooth device connected with a wire voltage splitter. And what you see on the screen is that the Bluetooth device is connects to the Bluetooth device connected to Arduino, and then from there it connects to LoRa Shield, and it goes through the gateway, and it goes to the LoRa WAN system through a local network, local gateway. So and then from there we catch the data again and we decrypt it, and all of these data over here is all encrypted. And from there the data is again saved into a SQL, and then it's sent over Swagger for other teams to use. So here we have a local web browser with a website, and now it's time to show you some of the code that we have. So to start with, I'm going to show you the drone part here, and here there's a drone you can see. I will leave a link for this video if you want to watch this. This virtual drone flies around and it calculates all the readings, and it sends over through the one of these Heltec boards which I was showing you earlier. This board. So one of them is on the a drone, and the second one is on the base camp. So that's that part, and then what happens is that the data is from there is sent over to what you call the local database, which is this one over here, and then these are the API calls coming in from this local base camp, and then the website is served over here, as you can see, and 3000. As you can see that from this API 8000, it goes to the 3000, which is the front end web browser, and we can see all the readings. They get loaded every 10 seconds or so, but the data is coming in from this port over here. This is a React website, and so from here the data is being traveled to the Bluetooth device, and this is being controlled by a Java program, and in which there's a client, and it sends the data over to the Bluetooth to the Arduino. So this is being sent, and as you can see that there is data coming in, and this is encrypted, and there is a something called a watcher. So message watcher, you can find that in the Git repository, and this is a folder, and it's called watch messages. As soon as you run it, it's a netcat program, and you can see the data coming in, and then this is just watching, it's not doing anything, and then here this is sent over to the LoRa Shield. So as we get through down here, so we've moved into this LoRa WAN, and LoRa WAN data, as you can see, the data has been loaded. I will close this for a second, and now we can see that the packets are coming, and now the data that's coming in, that's encrypted by encryption, and that is again converted into a hex, ASCII code. So if I want to decode this back, I have to copy this and I have to paste this over here, and we can see that the last message that came in was HRAE. And if I look at here, and we can see HRAE, and this is the point where the data is being sent over to the Bluetooth or over to LoRa Shield and onto the TTN network. We can see that these data are coming in every 90 seconds. We've set the dummy data to being collected from the drone every 90 seconds. So this is coming in perfectly. From there, the architectural design says we receive that data on the other end, and we are receiving that data in a different server. And as you can see, everything has been deployed online. These were Docker images, and I have Mikhailo. He's going to explain this part of the process.
Yeah, so basically the data is received on the Node.js server.
Then the data is decrypted using AES 256 decryption. After that, the data is then stored in the database. Um, so after the data is stored in the database, the users can retrieve the data using API server, which you can see on the architecture design. Third, yeah, the blue one, that one. So there are three routes in our API server. The first one is aus. Aus is of course used to authorize to authorization for authorization, and after the user is authorized, yeah, I think you need to send a post request. So after the user is authorized, he can ask for data by using measurements route or measurements all route. Measurements gives us the data in the last 60 minutes, and measurements all gives us all the data. Also, we created a Swagger to describe our routes. Here you can see on the screen. Um, yeah, so here you can see the routes, out, post, get measurements, and you can see that in order to get the measurements, you need to specify barrier token. Yeah, so this is how it works.
Okay, so that covers all of the charts in this architecture plan. All of our parts of the project works. Um, we've deployed the parts on the internet. The server is not very reliable, but we have tested them and tried to get all the data coming in and being received on both ends, on this side and this side. I hope you maybe learned something from this video, but it's a demonstration to show our work, and I will leave some links in the video, and you can click on them, and if they're still online, you can visit and look at some data. Thanks very much. Go.
Thank you, everybody.